Hello, greetings, and welcome. Let's take a look at our first critical path method example from Chapter 7. So here we go. So the table at the end of the problem provides precedence relations for sample network. 1. Use the forward pass to calculate the earliest possible starting and finishing times of all activities. 2. Use the backward pass to calculate the latest allowable starting and finishing times for all activities. And C, calculate the total floats of all activities. And then finally, determine the critical path. Okay, and so here's an example precedence table we're provided with. And so I'm going to tackle this in two parts. So first, I'm just going to take the information from the first two columns, and I'm going to construct a network in which I go from some starting node to some terminal node, and then that network then in between will be connecting activities A through J. I'm going to start though with some initial starting and some terminal node to make sure I tie up any precedence relationships. And then after I create this initial precedence network, I am then going to redraw my precedence network, only I'm going to replace my nodes in which I just have the activity labeled with that table essentially of 9 cells, right? 3 rows of 3 columns, in which I include also the information from part 1, my earliest possible starting and finishing times in my first row, the latest allowable starting and finishing times, so point 2 from my backward pass in row 3, and then the floats in row 2, so which I calculate and include all of this information. So I'm going to do it in 2 steps, just so I can make sure I have the network right and the relationships down right before I add in these more details. And then the connections, at least for me initially, are good for when I draw this more complicated network. Okay, so without further ado, let's give it a try. Okay, so I'm going to start with some initial starting node. Okay, and then I see I have activity A with no immediate predecessor. Okay, so I'm going to go from my starting node to A. Okay, and maybe I can draw that a little better. Okay. And so then let's look at activity B. Activity B has the precedence of A. Okay, so I'll say let's go from A to B. If I look at C, C has a precedence of A and B. Okay, so I'm going to label node C here, and I'm going to have an arrow going from A to C and B to C. Okay, now C has a precedence of A and B, so both A and B need to be completed before C can begin. Okay, so it might be tempting just to have an arrow from B to C, since thinking in terms of path, I must go from A to B and then B to C. But this will be accounted for when we calculate our earliest possible starting and finishing times and our latest possible starting and finishing times. Okay, so all will work out just fine. So D is going to have a precedence of just B, so I'll have an arrow just from B to D. E is dependent on B and C. Okay, so I'll have an arrow going from B to E and from C to E. F is dependent on C, D, and E. So I'll draw F here, and F is going to be dependent on C, D, and E. Okay, next I'll draw G. G is just dependent on D. Now H and I are both dependent on F and G. So I'm going to draw H and I, and both are going to be dependent on F and G. And then J, okay, so finally J, which is only dependent on I. Okay, and then I'm going to have some terminal node. Okay, so I'll call it NT. And I'm going to connect to NT both H and J. Okay, because here's our two kind of terminal tasks which don't connect to anything else. Okay, so I'm going to connect H to my terminal node and J to my terminal node. Okay, cool. All right, so now that I have this, I'm going to go back and I'm going to essentially redraw my network, only I'm going to have a large box for each node, which will then divide up into a table with 3 columns and 3 rows, where the middle will be labeled as my activity. Okay, so the exception to this is NS just stays as NS. Okay, so I'll keep this as NS. Okay, and I'm going to try and shrink down my arrows because I'll have these big blocks. And I guess they don't need to be that big. Okay. So as I draw my table, okay, in the middle is the activity. Activity immediate to the left is just going to be blank. Okay, so there's A. Okay, now I'm just going to draw a block for B and C. And maybe I might try and just label out blocks for all of these and then draw out the arrows. And then I'll worry about connecting and labeling. And the hope is that as we do more and more of these, that we get better and better at drawing them. But just try your best to make it as clear as possible. You know, as clear mostly so it makes sense to you to try and prevent any mistakes. So ABC, next I'm going to do D. And E. G and F. H and I. Okay, J. And then our terminal node. Okay. Now connections. So we had A to B, A to C, B to C, C to E, B to E, B to D. Oh, accidentally had eraser on there. D to G, D to F, E to F. Oh, if I have to scroll down a little bit, C to F. C to F. Let's see. So F has those 3. D to G, D to F, E to F, C to F. Okay, so G to H, G to I, F to H, F to I to J. Then we had H and J connected to our terminal. Okay, and hopefully that's everything. Now the next thing I'm going to do, okay, is I'm going to go through our network now, and I'm going to add on our durations. Okay, so our duration of activity A is 5. So I'm going to label, duration of 5 weeks here. B is 3. C is 7. D is 4. E is 6. F is 4. G is 2. H is 9. I is 6. And J was 2. Okay. So now I'm going to change my color to yellow, and I'm going to do a forward pass. Okay. So when I do my forward pass, I'm going to start by saying that my project begins at time equals 0. Okay. And now what I want to label is, based on my precedence relationships, the earliest possible starting and finishing times. So when I look at A, okay, so when I look at node A is just connected to my starting node, which starts at time equals 0 and has a duration of 0. So the earliest possible starting time for A is 0, can start immediately, has a duration of 5, so the earliest possible finishing time is 5. Okay. Now let's look at B. Okay, so B is just dependent on A. So B just has a precedence of A. So the earliest possible finishing time of A is 5, so 5 weeks. So the earliest possible starting time for B then is 5 weeks. B has a duration of 3, so the earliest possible finishing time then for B is 8. When I look at C, so C has a precedence of both A and B. It's connected to both A and B. The earliest possible finishing time for A is 5 and B is 8. So if both need to be completed before C can finish, the earliest possible starting time for C is going to be the maximum or the largest of the earliest possible finishing time for all of its precedence relationships. Okay, so I'm looking for the maximum of the earliest possible finishing time of A and B. Okay, so that's going to be from B, which is 8. Okay. So C has a duration of 7. Okay, so that's going to give an earliest possible starting time of C of 15. All right, let's go up to D. So D just has a precedence of B. So the earliest possible starting time of D is 8, okay, which is that earliest possible finishing time of B. Has a duration of 4, so the earliest possible finishing time of D is 12. E, so now E has a precedence of both B and C. So I'm looking at the maximum of the earliest possible finishing time of all precedence relationships. So I'm looking at the largest of the earliest possible finishing time of B and C. Okay, so that's going to be due to C, which is 15. Has a duration of 6, so the earliest possible finishing time is 21. I go to F. F has precedence relationships of C, E, and D. So I'm looking at the largest or the maximum of the earliest possible finishing time of all precedence relationships. So that's going to be E. So it's going to have an earliest possible starting time of 21, a duration of 4, so earliest possible finishing time is 25. G just has a precedence of D, so its earliest possible starting time is 12, a duration of 2, so earliest possible finishing time is 14. H is dependent or has a precedence of G and F. Okay, so its earliest possible starting time is going to be due to F, which is 25. Has a duration of 9, so its earliest possible finishing time is 34. I is also dependent on G and F, so its earliest possible starting time will likewise be 25. Has a duration of 6, so its earliest possible finishing time is 31. J is only dependent on I, so earliest possible starting time is 31, duration of 2, so earliest possible finishing time is 33. Okay. My terminal node is connected both to H and J, so the earliest possible finishing time of H is 34, J is 33, so the time it takes to get to my terminal node is going to be the largest of those two earliest possible finishing times, which will be due to H, which will be 34. Okay. Bam. So the time it takes to get from to take this project to completion is going to be 34 weeks. Okay. Now we need to go backwards. Okay. So let's do this. So as we go backwards, so I need to make sure I think through this too, because now my arrows are essentially we're going in reverse. Okay. All right. So in terms of going backwards from NT, so let's start with say H. Okay. So if my project is going to complete, my project is going to take 34 weeks to complete. Okay, so the latest possible starting time then for H is going to be 34. Has a duration of 9, so the latest possible starting time is 25. All right, so from here, I'm going to go to J. Okay, J, the latest possible starting time is likewise going to be the latest possible finish time is likewise going to be 34 weeks, has a duration of 2, so the latest possible starting time is 32. Now as I go from look to I, okay, so J is connected to I, so working backwards then, if the latest possible finishing time of or starting time of J is 32, the latest possible ending time of I is likewise going to be 32. It has a duration of 6, so its latest possible starting time is 26. All right, so how do we proceed from here? So if we go and look at F next, okay, so F is connected both to H and I. Okay, so H has a latest possible starting time of 25. I has a latest possible starting time of 26. Okay, so when I go backwards now, that's going to tell me the latest possible finishing time of F is 25. Because if it finished any later, then H wouldn't start on time, right? And we'd have issues. Okay, so when I go backwards, if I'm connected to, in this case, both H and I, I'm looking at the latest possible starting times, and the latest possible ending time of F is going to be the minimum of those two values, because we need to make sure that F ends at the latest by week 25 to make sure that A can begin on time so that I can get to my terminal node or complete this project in that 34 weeks. Okay. So F is going to have the latest possible finishing time of 25, so the latest possible starting time then is 21. If I look at G, G likewise is connected to H and I. So again, the latest possible starting time then will be 25. It has a duration of 2, so it needs to begin by week 23. So its latest possible starting time is 23. Okay, cool. Now as we go backwards, let's go to D. Okay, D is connected to both G and F. Okay, so if I look at the latest possible starting time for G, G is 23, F is 21. So the latest possible finishing time for D then is 21. Has a duration of 4, so it has the latest possible starting time of 17. If I look at E, okay, going backwards, E is connected to F. So F has the latest possible starting time of 21. So the latest possible ending time of E is 21. Has a duration of 6. So its latest possible starting time is E. Okay, let's go to C. So C is connected to F and E. Just trying to make sure I'm keeping track of everything. These things, especially for me, when I go backwards, I can get a little mixed up. So C is connected to E and F. So I deleted E. Okay. So I'm looking at the latest possible starting time for E and F. Okay, and the latest possible finishing time for C is going to be the minimum of those two values, so I can make sure it's complete on time, or the next job can start on time. So C is going to be 15, okay, which is the latest possible starting time for E. Has a duration of 7, so the latest possible starting time is 8. I go to B. B is connected to D, E, and C. So I'm looking at the latest possible starting times for C, D, and E. The smallest value is C, which begins at needs to begin at 8. So the latest possible finishing time for B is 8. Has a duration of 3. So the latest possible starting time is 5. Then that brings me to A. It's connected to B and C. So I'm looking at the minimum of the latest possible starting times. That's due to B, which is 5. Has a duration of 5. And so that brings me back to 0. Okay. All right. So I'm going to change my colors one more time to green. And so now I need to calculate my floats, which are going to appear next to my activity. Okay. So where's my cursor? Okay, there we go. All right. So now to get my floats, so if I start at my first node, okay. So the earliest possible starting time for A is 0. Earliest possible finishing time is 5. Latest possible starting time is 0. Latest possible finishing time is also 5. Okay, so if I look at the range from my, how do I want to put this, right? So if my earliest possible starting time and latest possible starting time are the same, and my earliest possible finishing time and latest possible finishing time are both the same, right? The float, right, the flexibility in which I have for that project to start and finish is 0. Right? It needs to, again, maybe I need to change colors because I can't see my cursor. Let me do like blue. All right, so my float here is going to be 0. Right? I have no flexibility in that window. Okay, B is likewise going to be 0. C is likewise going to be 0. Okay. Okay. Now we have some range, right? So when I look at D, okay, so D, okay, the earliest possible starting time is week 8. Earliest possible finishing time is 12. Latest possible starting time is week 17. Latest possible finishing time is week 12. Okay, so what that tells me is, if I compare my earliest possible and latest possible starting time, that's 9. Okay, so I have a range of 9 weeks between the earliest possible starting and latest possible starting time. Okay, so my float is going to be the difference of those two values. Okay, that gives me the flexibility in a sense in terms of when I start. Because if I start at any time between week 8 and week 17, I can complete on time in 34 weeks. Okay. So E, okay, the float is 0. Okay, now G, okay, earliest possible starting time is 12, earliest possible finishing time is 14, earliest possible or latest possible starting time is 23, latest possible finishing time is 25. So again, I have flexibility this time of 11. Okay, so I have an 11-week range over which activity G can begin, and I can still finish on time. F, floats 0, right? Those ranges are the same. H, floats are 0. Those ranges are the same. I have a flexibility of 1 week. Earliest possible starting time is 25. Latest possible starting time is 26. All right, so I have a range of 1. J, likewise, I have a float of 1, a variability of 1 over which that activity can occur. Okay, so now I've done my forward pass, my backward pass. I've calculated my floats. So essentially that flexibility in weeks in this case over which a project can begin and still end on time. Okay, and so now what I'm doing is I'm looking. Now I want to identify my critical path, right? And so let me try getting something like yellow. Okay, and so I'm just going to try and star if I can see my cursor. Okay, this is going to be problematic because I can't see my cursor. So let me go back to blue. Okay, so I'm going to star all of my critical activities, my activities that have a float of 0. Okay, because what this tells me is that my critical activities, there's no flexibility in when they begin or end. Okay, whereas when I get to say D, I have flexibility. So I have A, B, C, E, F, and H are all critical. So my critical path then would be, say, A, B, C, E, F, H. Okay. So I've identified a critical path. Okay, so my critical path is going to be A, B, C, E, F, and H. Okay, so these are all activities with a float of 0, which means I need to make sure, that I have no variability when they begin. Right? There's no room. So A needs to begin at week 0. B needs to begin at week 5. C needs to begin at week 8. E needs to begin at week 15. F needs to begin at week 21. H needs to begin at week 25. Any delay in any of those will cause a delay in my completion time. For comparison, D, which has a float of 9, that activity could begin anywhere between week 8 and week 17. Right, so I have a range of 9 weeks over which I could begin that project, and my overall, or which I could begin that activity, and my project will still be completed on time. Okay, so there you go. So there's our first critical path method, where we identified our critical activities, and then that critical path to go from our starting point to our terminal point. And those are going to be all our activities which need to be started on time to make sure my project can be completed on time. Okay. Good. We'll try some more, and hopefully once we do enough of these, they'll become second nature. All right. If you have any questions, by all means, let me know.